Hello students. So the given question is based on LAMI'S theorem. So the question is if O is at equilibrium, then the value of the tension T1 and T2 are XY. If 20 Newton is vertically down, then XY. So we are going to find the XY. So we know by LAMI'S theorem, I am giving this formula here. So F divided by sine of angle between the other two forces is equal to, for example, I am taking it as a constant. So here x and y, that is nothing but T1 and T2 we are going to find. T1 and T2. So as per the diagram, so here once again I am drawing the diagram here. So the given diagram, and T1 and T2 are the forces which are acting. So T2 is acting here and T1 is acting here. And here some 20 Newton is acting downwards. And the given angle between T1 and T2 is 150 degrees given in the question. And this angle is 60 given. This angle is also 60 given. So now we have to find T1 and T2. So apply LAMI'S theorem. So here I am writing T1 divided by the angle between other two forces is this one, right? The angle between 20 and T2 we are going to consider. So what is our formula? T1 divided by sine of the angle between T2 and 20. So here I am considering, for example, from this point I am drawing horizontal line. And we know that, for example, this is O. Some naming I am giving. This is A, this is B. We know this is one right angle triangle. This angle is 60 means this is perpendicular, so 90. Then what about the other angle? Sum of all the angles of a triangle is 180. So this is 60, the other is perpendicular 90. Then this angle is 30 degree. So 90 plus 60, 150. 150 plus 30, that is 180. So this is 60 means what is this one? 90 minus 30, this is 60. Sorry, this is 30, then this is 90 minus 30. So this angle is 60 degree. So the angle between T2 and 20 is 60. So T1 divided by sine 60, which is equal to the other force, which is tension T2 divided by sine of. So sine of, now we are going to consider the force, the angle between T1 and 20. So T1 and 20. Now I am extending this horizontal line like this, and now we know this is the angle 90 degree. So we are going to find this angle. So for that I am drawing one vertical line which is upwards like this, and this is 90, that is perpendicular. So 90 plus 60, which is 150. Then this angle will be 30 degree. So this is 30 degree. Then this angle will be 90 minus 30, that is 60. So this is perpendicular. So 90 plus 60. So the angle is 150 degree here. So T2 divided by the other two, the angle between the other two forces, that is T1 and 20. That is sine 150, which is equal to the other force which is acting downwards, that is 20 divided by, anyway they have given in the question the angle between the other two forces means T1 and T2 is 50. So sine 150. Now we can find T1 and T2. So easily we can find, for example, if you equate these two, we can find T2, right? So T2 is equals to 20. Why? In denominator, sine 150, sine 150 get cancelled. Then finally T2 is equal to 20. So now we are going to find T1. So I am equating first two. This is one, for example, 1, this is 2, this is 3. So first two, if you equate, then 1 is equal to 2. Then we will get T1. Sine 60 is equals to root 3 by 2. So 2 I am writing in the numerator, which is equals to T2. T2 already we got 20 divided by sine 150. So we know that sine 150 is equals to 1 by 2. So 1 by 2. That is nothing but, how to find? We know sine of 90 plus 60. Sine of 90 plus 60 comes under second quadrant. That is positive. In second quadrant we know sine is there, that is positive. So 90 plus 60. So function changes from sine to cos. Cos 60. We know that cos 60 is equals to 1 by 2. So finally we got here sine 150 is equals to 1 by 2. So 1 by 2 means 2 goes to numerator. So from here 2 and 2 get cancelled. Then finally what is our T1? T1 is equals to 20 root 3. So finally we have shown T1 and T2. So T1 is 20 root 3 and T2 is 20. Thank you.